Our first functional group, which really is not a functional group, family of hydrocarbons that we'll be looking at is the alkanes. Now, alkanes have no functional group, as I just said. Okay, so this is going to be a very fundamental chapter for us. We will start with nomenclature for this because the rules that we learn for alkanes will generally follow through for the entire organic chemistry. So this is really, I think maybe I say it for everything, a very important chapter. Let's just do a little bit of a review for alkanes, and this is something that you already know, so I'm just going to go through it. So hydrocarbon is anything that has only hydrogen and carbon, and that's all we are studying here right now is just hydrogen and carbon. Saturated hydrocarbon is the one that has only single bonds in it. Alkane is all single bond, and it's arranged in an open chain, which aliphatic hydrocarbon is also another name for alkane. So that's one thing that you will encounter in organic a lot is sometimes we have more than one name for things, okay, which we will learn here also, okay, as we're learning nomenclature. So aliphatic is one thing. Aliphatic is also more for straight chain compounds, and we also have cyclic compounds, so anyway. Then we've done organic structures already, and the organic structures that you know of are so far molecular formula, condensed formula, and in the structural formula you have learned about the expanded and of course the line structure. Okay, so you have all of these different kinds of formulas that you have already learned. So now for naming of organic compounds, there's a very systematic method. Okay, so there is an agency called IUPAC or IUPAC, which is the International Union of Pure and Applied Chemistry. And what they do is they set a lot of rules, not just for naming, but all other things also. But naming is also one big thing, okay, because things have to be standardized, all right? When we say the name of a compound, you and I should draw the same compound, okay? So the name should clearly indicate which compound we are talking about. That's the most important thing when you name something, right? We should be talking about the same thing. So it's a very systematic name, okay? But IUPAC came later on, and so before that, we had general nomenclature. So the general nomenclature also we follow. So, you have to sometimes learn two names instead of just the IUPAC nomenclature. Okay, so I will mention that to you as we go on as to what is general and what is IUPAC. So that way you are clear. Okay, now do I need you to know both? In some cases, yes. Okay, I will need you to know both. All right, so here let's look at one of the most fundamental things about organic chemistry, and that's because we have families. Okay, so when you have an alkane, you're not talking about just one compound, you're talking about a class of compounds that belong to the same family, to the same category, which have the same properties. And I'm not talking about physical because they can change according to the size, intermolecular forces and whatnot. But we're talking about chemical properties, all right? So they all belong in one class of compounds. So for that reason, you're going to have many, many, many carbons, okay, in there. And yes, almost in all organic compounds, you start with one carbon structure, go on to 2, 3, 4, 5, and you can go on up to 20, 24. It depends on the nature of the compound. Okay, and I'm talking just simple straight chain compounds. Okay, so you can take anything from an alkane to an alkene or an alcohol, and you will find chains and chains of compounds, okay, in there. And by chains, I mean like, 6-membered or 7-membered, 10-membered chains that you can find. So which means we have to have a way to address the number of carbons we're dealing with, okay? And so this is how we deal with this. So one carbon, the prefix for that is meth, okay? Now what's going to happen here is that you're going to have some prefixes, you're going to have some suffixes, okay? So prefix is the number of carbon, the suffix generally is going to be the functional group, okay? So in our case is going to be alk and then ane. So alk is the number of carbon. Ane, suffix ane, is going to be the functional group. Okay, so if we have to name the first carbon, that's going to be methane in an alkane. And I'll give you some more examples as we go on, but for alcohol, it will be methanol. So meth tells you right away you have only one carbon. Two carbons is eth. So two carbons for an alkane would be ethane. Two carbons for an alcohol will be ethanol. Two carbons for an aldehyde will be ethanol. So you can say prefix and then suffix, right? Suffix is telling you what kind of functional group you're dealing with. Okay, so let me not get stuck here. So 3, 4, 5, 6, and then pro, bute, pent, hex, hept, oct, non. The first four are a little bit different. Meth, eth, prop, bute. These are a little bit different because they're coming from an old nomenclature system. But after that, C5, pent is a very common kind of a prefix. Okay, we use for a lot of things like pentagon, for example, right? Anything that has five sides is going to be a pentagon, hexagon. So that's kind of a little bit more math oriented. And so this is something we are more familiar with. So pent, hex, hept, oct, non, dec. These all make sense as in 5, 6, 7, 8, 9, 10. But the first four are a little bit different. Okay, so this is something you'll have to memorize. There's no other way to do this. Okay, but trust me, you will be fine, okay? Because by the time we do all the nomenclature, you will know this, okay? And so these are the number of carbons. Again, these are the prefixes. And so here I've given you some examples on how this works. So alk and then ane, so eth and then ane. If it was an alkene, alk is the number of carbons, eth is the number of carbons, ene is ene, so ethene. As soon as you say ethene, then everybody knows you're talking about two carbons and an alkene functional group, okay? So here's alcohol and so on. So as we go on, we're going to learn more and more, of course, you know, that's how it is. So naming straight chain alkanes. So this slide just gives you a little bit more for just the alkanes, okay? The other one was the prefixes. And by the way, if you're thinking that I gave you only 10 prefixes, don't we have more? Yes, we do have more, but we are going to focus more on the 10, okay, over here, because you can have large chain compounds also. So here you will see we have a C12 and 20 up to 20, but you know, ICOS, we don't really use it that much, so I'm not teaching you, and you can thank me because, you know, why put so much pressure on your memory? I have so many more other things for you to learn. Okay, so these names that I've given to you, these are for some of the alkanes. So the first 10 you definitely should know, right? So methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. All right, this much you should know. All the other ones you don't have to know, but know that there are names for all the other ones too. Okay, and you can see I skipped completely between 13 and 20, and that's fine. It doesn't matter because you don't have to worry about naming those kind of compounds. Okay, up to 10 is what I'm expecting you to know. So here are some general rules, and again, you don't have to follow everything right now because right now we're focusing on alkane, but I just want to have this slide in there so in case later on you're looking at something and you want to look at the rules, they're right here. But as we do all functional groups, I'm going to go through all of these with you, but in case you find something, you know, as we are going along, because sometimes we tend to forget and I write compounds which I haven't really dealt with yet, and you see a name, I don't want you to be I don't know, you know, get mad at me, okay, that she didn't teach me the name for it. All right, so I'm not teaching you the proper nomenclature for it, but I don't want you to feel lost either. Okay, so I talked about the prefixes, all right, and then here is the infix. Now there are infix and there's suffix, okay, and infix and suffix have to do with if you have more than one functional group. Okay, so if you have an alkene and an alcohol, so the priority will be the suffix. Okay, if you have only one functional group, then this is it, suffix is it. Okay, but if you have two, then you have to give priority. And as we go on, as I said, you know, we will learn about these priorities. At this point, again, I'm not going to ask you nomenclature without teaching you nomenclature for each functional group. So this is just kind of an idea of what happens. Okay, so prefix is the number of carbon, infix is one functional group, suffix is the other functional group, the higher priority functional group. Okay, because, you know, you can have more than one functional group in a compound. So the suffix here, okay, so for example, when I was telling you about ethanol, So ethane, all. Okay, so all tells you that you're having an alcohol. Al tells you have an aldehyde. Amine is amine. On is ketone, oic acid, carboxylic acid. So you can see it's very easy to recognize that you have a functional group and which functional group it is. Okay, so ene and ine, perfect. Okay, that's totally fine. Now for us, the infix is going to be an. Okay, for most part, because we are dealing with a lot of alkanes. So methane. Okay, you got it? Methane. So the suffix here for the hydrocarbon is E. So methane becomes our functional group. Now, if we're dealing with methanol, so methanol. Okay, so that is kind of how it works. Ethanol. Ethanol. All right. Hopefully you got it. Okay, if not, it's okay. We will learn as we go on. Here are some examples also, so you can see how the infix and the suffix are working for us. So go through these yourself if you want to, but you can see how propene, for example, will tell you right away that you have an alkene, ethine, ethanol, and look at the prefixes. Okay, you can tell how many carbons you have in there, and then the ending will tell you the functional group, okay, that you have. So these are just examples. I don't want you to get lost because, you know, I mean, we go through so much stuff in organic, and sometimes we end up using an aldehyde when we are not really talking about aldehydes, but I don't want you to feel like I can't name it, okay? Or you should know at least what it's called. Okay, so let's focus now on the alkanes. Okay, so there are a lot of rules that we're going to learn, but trust me, they're going to become very easy for you. But I wrote them all down. So in case you're lost, you just come back and look at the slide. Okay, so first of all, the most important thing for us is to find the longest chain. Okay, again, you know that in my book, I have a lot of practice sheets for you, and you should use those because one of the first questions I ask you in that is to find me the longest chain, because that's the biggest problem we have sometimes in nomenclature, is just finding the longest chain. Okay, so find the longest chain of carbon. That doesn't have to be the horizontal one. It could be going zigzag, it could be going up and down, whatever it is. Okay, number the carbon starting closest to the first branch. Okay, branching mean that when you have carbons coming out of the chain. All right, so let's say that this is your chain, so you can have a branching here, you can have a branching here. This is closest to the branching, so start numbering here. 1, 2, 3. That's what I mean. Okay, not 1, 2, 3. That's too far. Okay, 2 and 3. 2 is smaller than 3. So use smaller numbers. Okay, so numbering starts, okay, at the chain which is closest to the group named in the suffix. And I said suffix here because suffix is supposed to be the higher priority group. Okay, so at this point it's not going to mean much for us because everything is alkane for us. But if you had alcohol and if you had a chlorine, which one do you name first, kind of a thing. Okay, so that's what's going to happen for number 3. And again, you know, we're going to use this much later. Right now focus on number 2 because that's the one which is going to be useful for us. Okay, but keep number 3 in mind as we go on, and I'll bring it up again later. Okay, name the groups attached to the chain. Okay, and this is what I do, and this is how I have written these rules. This is what I do when I am naming something. Okay, so for example, I will name this and I will name this. Remember, this long chain is going to be our parent name. Okay, this is the base name, so it's like the city that you live in. Okay, so that's the city name, that's going to be the base name. And then here what you have is going to be these branching that's coming out, and those branches is what I'm talking about, is just name them. Okay, and yeah, right now you don't know how to name them, but we're going to learn how to. Okay, all right. Then alphabetize the substituents. So if these two groups over here were the substituents, here these groups, alphabetize them because they're going to have different names. If they have the same name, yeah, then we're going to use the di, tri, tetra. You know how we use for back in Gen Chem when we learned about how many things we have in there, like, you know, carbon dioxide, right? So di. So we alphabetize substituents, and if they are the same, then we are going to use the di, tri, and all that. But the di, tri, tetra, these are not used for alphabetizing. Okay. Okay, so for example, if you have chlorine, if you have bromine, you know, bromine comes before chlorine, so that's alphabetization. All right, the dichlorine, dibromine doesn't mean anything, okay, because the di is not part of the alphabetization. Okay, so an IUPAC name can have a lot of things in there. Okay, so you can have locant prefixes, parent name, suffixes, blah, 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 so many things because you can have such a big name, right? Because right now we're focusing on alkane, but you can have a really large compound. Okay, so next slide is a pictorial. So here is a pictorial. Okay, I want to focus on the pictorial first and then we'll get to all of this. Okay, so in the pictorial here, it shows you that you have a locant and a prefix and a parent and a suffix. The parent is the longest carbon chain. That's what I was saying. That's the first thing that we do. Suffix is the highest priority group, okay, that we have. Locant is where the substituent is, which is a number, okay, generally, all right, that's what it's going to be. And then prefix is going to be what the substituent is, okay. So there's so many things here: number, substituent, longest chain, and then functional group. Okay, that's how it goes. So that's what we have here. So here is an example of what each of these things is going to look like. Now here you can see I have two numbers, okay, so you have two locants, okay, and that's why this thing is nothing is set in stone, okay. There are certain things that rules we follow, but here the locant, you can use it again and again, because if you have more substituents, you're going to have to repeat this thing again and again, okay. You cannot repeat the parent again because that's the longest chain. You can't repeat the suffix again, okay, because that's going to be the highest priority group. But the locant and the prefix, you can repeat this, okay, because depending on what kind of groups you have in there. Okay, so here you can see that the longest chain is 1, 2, 3, 4, 5, 6. Okay, so hex. All is the suffix, that's the highest priority functional group, all, and then the numbering goes in there. Okay, and then we're going to learn about substituents, okay, in a few minutes. Okay, so this is your basic rules. Okay, then there are some other things that we also follow as far as the rules are concerned, and I want to show you with what we have over here. So use hyphens between number and letter. So I have put it in red here for you, 3-methylhexane. So it was a dash. That dash is an important one. You can see that here also. Okay, anytime you have a letter and a number, you have to put a hyphen or a dash. Okay, use a comma between two numbers. Here we don't have two numbers, but here I have given you an example. So 2,3-dimethylhexane. Okay, so if you had two groups, they are on different carbons on the second and the third one. So between the two numbers, put a comma, not a dash, comma. There is no space between substituent and parent name. Okay, so you can see here also, I didn't leave any space, methylhexane. So methylhexane, it's not one word, but in the name it is written as one word. Okay, which means that you and I, we all know that methylhexane is nothing. Methyl is a substituent and hexane is the parent chain. Okay, now for this one, in the beginning I say you can try a little bit to make your life easy by writing like this. Okay, if you want to, so you can say like this. Okay, now I don't encourage that too much. Okay, in the beginning I say, okay, give a little space if you want to, but generally I would say don't. Okay, because it's not really the rule. Okay, but sometimes we have to. Okay, because the name becomes too long and then you're like, oh, this doesn't make any sense. Okay, and so sometimes we do that, and then as we learn more, you will learn more and more rules. Let's get started then. All right, so the first three alkanes are fairly easy: methane, ethane, propane. Okay, so first carbon, two carbons, and then three carbons that we have, and that's propane. I've given you the condensed structure over here. I have said before to you also that I prefer, okay, not we, I prefer line structures to anything else because it helps me clearly see what I am dealing with. Okay, and so you will see me use line structures a lot. Okay, so then the fourth alkane, I've put that over here because I want to talk more about this. The fourth alkane is butane, all right, and butane is 4 carbons, so but and then ane. So the constitutional isomer of butane is this, okay, which is shown over here. So this is the branched isomer. The alkane itself is straight chain, okay? So why am I going over this? I'm going over this is because this straight chain and this constitutional isomer of that butane, they have the same number of carbons, but they will not have the same name. Okay, so I start my nomenclature like that, so you can see how this is going to work out. Okay, because it's a very simple name now for us. All right, because we have such few carbons, it doesn't matter. So you will see from now onwards, I have used two colors in my nomenclature, and the red one, in this case, it's correct, but generally the red one is wrong and the blue one is correct. Okay, so in this case, both are correct, okay, because it's a small compound. All right, so how do we name this? Okay, because this is not butane. Butane is the straight chain. So this is still 4 carbons, okay, but it's not butane. All right, so how do we name this? You find the longest chain, okay, which I have numbered here for you as 1, 2, 3, going from left to right, and then left to right, and then right to left. They're both 3, and then if you found the fourth one, it is 1, 2, 3. Okay, so third one, sorry. So there are 3 ways you can name, and all of them are coming out to be 3 carbons, which means that our base name for this one is going to be propane. Okay, so there is no other thing possible. So propane, that's going to be our base name. On the second carbon, we have a branching going on. Okay, and that branching is a CH3. That CH3 group is called a methyl group. Okay, so there are a few things here. First of all, the locant. The locant is 2. The group itself, the branching is methyl. The base name is propane. So the name then becomes 2-methyl-propane. All right. So this is what I was telling you before. Find the longest chain. Do the numbering closest to the chain here. That's closest to the branching and to the end of the chain, which here it's equal on either side, on any side actually. Name the group. Okay, and since here we have only one group, we don't have to worry about alphabetization. So here this is going to become 2-methyl-propane, a simple name here. Okay, nothing much going on here. So, but this gives you an idea of what is to come. So here, this is a longer chain now. All right, so in this case, again, I've given you the red and the blue one. Remember, the red ones are always going to be wrong and the blue ones are going to be correct, because even when I'm grading, the red's always wrong, okay, in there. So it helps hopefully with your color coding. Okay, and so here we find the longest chain, and the longest chain is 1, 2, 3, 4, 5, and that's going to be a pentane. And then there on the second carbon, there is a group coming out. So 2 is the locant, and the group that's coming out is going to be a methyl group. Okay, so I still have to talk to you about methyl group, okay, in just a second. Before I go on into all that, let me explain to you what a substituent is, because this is a new word that you're learning here. Okay, and I try to explain everything in my notes as I am, I would write for myself in my own notes. All right, so what's happening here with the substituent, okay, is if you look at any kind of a substituent here, so CH3 is the substituent, right? If CH3 was not there, what would be there? It would be another hydrogen, right? Because it's CH2, 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 CH3. So everything in the middle is a CH2. Okay, so you start with a CH3, CH2. If you go on from propane to butane, what do? You add another CH2. And you go on to CH3, you go on to pentane, and what do you add? You add another CH2. So you keep adding CH2, CH2s in the middle, all right? So which means that here it would have been a CH2 if it was not for this group. So what happened? This group became a substituent because it substituted one of the hydrogens. Okay, that's how the word substituent is coming, and I know I explain a lot of things in detail, a little too much. So if it is too much for you, you can forward me, all right? You can just, fast forward. Okay, so here we go. That's what a substituent is. Now we're going to learn a little bit more about the methyl group itself. Okay, like where did you get the name from? So these are called alkyl groups. Okay, the methyl group itself, it's called an alkyl group. So where is an alkyl group coming from? Okay, so again, remember our nomenclature like methane. What is methane? Meth is the number of carbon. This was the infix and this is the suffix, right? So now what are we doing? With the alkyl group, the alk is the same, which is the number of carbons, and then il is going to be telling us that we actually have a kind of a, I shouldn't say it's a functional group. It's not a functional group. It's kind of a family, okay, of alkyl groups in which you're missing one hydrogen. So when we say we have a CH3, what is it? It's CH4 minus one hydrogen, and that gives us a methyl group. A methyl group cannot exist on its own because it's CH3. Carbon cannot have 3 bonds, okay? So this does not exist, okay? So which means you will always see a little dash next to it there, all right? And that dash, I generally like to have this kind of a curvy line, so that tells you that this is connected somewhere. All right, and that's how we indicate groups. Okay, and you will see these lines, and I couldn't draw curvy lines there, but otherwise if you want to, you can. So just put a line there. So you have a CH3, and then this is kind of connected somewhere. You can leave it like that also, provided you know it's not a minus and it's, you know, a bond. So which means the CH3 has to be bonded to something. Okay, it cannot exist on its own. You must know that. Okay. So hopefully we're all good, okay, with what an alkyl group is. So now the alkyl groups can be different kinds because that can depend on the number of carbons we have. So if you have one carbon, it will be methyl. If you have 2 carbons, that's going to be an ethyl group. Okay, so for ethane, the alkyl group is ethyl. So you have CH3, CH2, and then I wrote this in 2 different ways because it depends on how you write the bonding. Okay, and this is really important because I find stuff all the time, and so I have to kind of mention this to you. Okay, so let's say you have CH3, CH2, CH, CH2, CH3, and then we write a CH2, CH3, right? So right here is the ethyl group. Okay, and the reason I said you have to put the wherever there is one less hydrogen, that's where the bond is going to be. Okay, so you can see that I changed where my bond is depending on where the number of hydrogens there. Why did I do that? Okay, and the reason I did that is because this is what I usually get. Okay, and now I'm changing my color coding here, but this is sometimes what I get is CH3, CH2, and the bond is showing here. Okay, you can't do that. Okay, look at how many bonds this carbon is going to have. 1 going to the carbon, and then 3 going here, and then 1 going here. That's 5 bonds. Okay, and this CH2 is bondless, right? So it doesn't have enough bonds. Okay, not bondless completely, but less bonds. So you have to be careful how you're bonding all of these things. Remember, connectivity is everything. Okay, I've been saying that from ever, and I will continue to say that. Okay, connectivity is everything in organic chemistry. So make sure that you put the bond in the right place. Okay, because if it's not, then you have the wrong thing. Okay, you can have more bonds and you completely have a wrong structure then. Okay, so methyl, ethyl, and then there is the propane group, which will give us propyl. Now, when you have a propyl group, okay, when you have 3 carbons, those 3 carbons can have the bonding on the end, or they can have the bonding on the middle carbon. Okay, when they have the bonding on the middle carbon, then that group is called isopropyl, and it looks like a fish, fin of a fish. Okay, not fish, like a fin of a fish, okay, or a V, whatever you want to call it. Okay, so isopropyl groups are a little easier to identify, or an iso group is easy to identify because it kind of looks like a V. A propyl group is just a straight chain which is connected to the end. Okay, so which means that again, connectivity, right? What I just said, connectivity is really important. If it's connected to the end carbon, it's propyl. If it's connected to the middle carbon, it's isopropyl. All right, so we have to be very careful. Now, later on, I will go over all the other groups also, because right now I want to get back to the nomenclature of alkanes, but I wanted to kind of introduce you to how I'm naming the methyl group. Okay, so you don't think like I have no idea what she's talking about. Okay, so methane becomes methyl, ethane becomes ethyl minus one hydrogen, right? Ethane minus one hydrogen is ethyl. Okay, moving on. So here's a little bit more thing over here about different kinds of substituents. Okay, so previously I was talking about branching. You start numbering closest to the branching. Okay, what I mean by numbering is you number the parent chain. Okay, you don't number the substituent. You number the parent chain because that's going to give you the locant. Okay, over here. Okay, so in this case, what is going on? In this case, your branching is more towards this blue one rather than the red one. Okay, and so for that reason, the blue numbering is correct. And if you do the red numbering, then your first locant here is number 3. So it's a higher number than 2. Okay, and sometimes, you know, this happens when you have a lot of branching. You have to be careful, okay, and make sure that you number from wherever the lowest number would be for the branching. Now here you have two groups that are the same, which are methyl groups. So you will write 2,4 dash dimethylhexane. Okay, so 2 and 4 are the locant. Di tells you that you have 2 of what? Methyl groups on hexane. Okay, so you don't write 2,4 methyl. Okay, you don't write that. You still have to indicate di, okay, in there. So that's what this is about. Okay, this example. The next example is about alphabetical order. So in this case, what happened is that I did not have different number of branching. I mean, not different number, different places of branching. Okay, so the branching is on the 3rd carbon. Here it is also on the 3rd carbon. Okay, this is going to be correct because you number from the larger branching and also from alphabetical. Okay, because this is an alphabetical order. Actually, let me take that back. It's nothing to do with the size. It has to do with alphabetical order. Okay, so if in both cases your numbering is going to be 1, 2, 3 and 1, 2, 3, then you pick the alphabetical order. Okay, so here ethyl and then methyl. Okay, so see there's 2 carbons over here. This is 1 carbon. Let me just give you another thing over here. Okay, another I don't know, clue. There's just so much to learn, right, when you're learning organic. Is when you have a group coming out, okay, as soon as you have a group coming out, that's a CH3. That's a CH3. This is a CH3. It's not a substituent, but on the terminal carbons, everything terminal is a CH3. Okay, and by the way, in the top one, if you're wondering, could I have done this kind of a numbering? You could have numbered this also for one. Okay, both of them will have given you the same thing. Okay, so it depends on how you're viewing things. We like to view things in a reading order, right? So horizontal, but you know, this is also correct. This is also number 1. This is possible, but it doesn't change the numbering in any way. Okay, so here what I was going to say is that here's a methyl group, okay, and this one is 2 carbons, 1 and 2, so that's an ethyl group. So this one becomes 3-ethyl 5-methylheptane. Don't forget the dashes, okay, you do need them in there. Don't do that in a chronological order. Okay, so numbering is numbering is the long chain and you start with the branching, but then when you name something, it's always done in alphabetical order, not in chronological order. Here is a little bit more with the di-tri prefixes and whatnot. So here it's a 6 carbon chain. Again, I don't know why I took so many of the 6 carbon chains, but 6 carbon chain meaning that your base name is hexane. Again, you could have put this as number 1 here or here. It doesn't change anything. Similarly over here, 4, 5, 6, right? So you can go up here also for numbering, and that also would not have changed anything. So 1, 2, 3, 4, 5, excuse me, and 6. Either way, just find the longest chain one way or another, wherever your vision is going to, and that's fine. So here you have two methyl groups on the second carbon, and then you have an ethyl group on the fourth carbon. So again, you have to do the alphabetization. So on the fourth, you have the ethyl, and on the twos, 2, 2 dash, then again dimethyl, and then hexane. Okay, so hopefully you're getting the gist of it and how to number. You know, the trick is always to practice, right? There's nothing that, you know, everything is absolute, that I can teach you everything in one slide. So here are some more examples, okay, and this is what I do. Okay, so that's why how I'm writing it for you also is I will number my longest chain first. I will find that first, and you can number it from either way, and then see which one fits. Okay, because then what I will do is I go through all of these and I say, okay, this is the numbering, this is my ethyl, this is methyl, you know, this is methyl. This is what I do. I don't write like this. I mean, you know, I wrote it there because this is a slide, but otherwise this is what I do. I make a mess of everything. So I have an ethyl, methyl, methyl, and then I'm like, okay, now I have to do the numbering part of it. So because this is an ethyl group and this is getting the smaller number, I mean, I can start numbering from here also to see if it's going to work, right? So I tried that. It doesn't work. Why? Because the ethyl can have the smaller number and also be alphabetical, so it can be both. Okay, and that's what we're doing here. So that's how you would number. Okay, so I hope you can understand everything else that's going on in here. So I'm going to leave it for you to see, because the groups are not all that different. What is kind of funky, especially in this one, is how the chain is going and how I can give you, like, see, if you think only horizontally, then the chain that you're going to look is, you're going to look at this chain, right? But that's not how we look at things. Okay, when we name things, then you need to look at them as far as the longest chain is concerned. All right, that's how you should view things for nomenclature purpose, and that's a rule. Okay, so I mean, there's nothing I can do or you can do about it. Just follow the rules. And then once you've you know, figured out the longest chain, which is the green one, then you start numbering from closest to the branching. And then once you have that, you go and, you know, you name each of those, and then you go from there. Okay, so I've given you the correct name and the wrong name as well, because one of the things that I like to do with you, and it's kind of fun to do, is I give you the wrong name and then I ask you to correct it. Okay, see what's wrong with that name. Okay, so here's a detailed look at the alkyl groups. Okay, so I mentioned to you about the isopropyl group, right? So isopropyl group is, you know, this kind of a group where you have 1 minus, you know, the CH3, CH3, CH2, CH2. That's the propyl group. And then this one here where you have a connection on the second one, that's the isopropyl group. Now, the isopropyl is actually a general name. Okay, remember I said to you there are two names in general for any kind of you know, compound. Not all the compounds, but you know, a few of them, they have general names. So isopropyl is actually a general name, which is accepted by IUPAC, so it's fine. Okay, that will work. But here's what happens, okay, when you want to give it an absolutely perfect IUPAC name, you have to do it a little bit different. How does it work? So you take from the connection point and you number your carbons. So from connection point, you number that carbon, and then you find the longest chain, which is 1, 2. It could be 1, 2 on either side. It doesn't matter, okay? Now, in this case, usually we say, right, you number the longest chain and then you number from where the branching is. Here, you have to number from where the connection is. Okay, so once you've numbered that, you have the 1, 2, and then on carbon number 1, you actually have a methyl group. So here's how you do the nomenclature for it. 1 methyl ethyl. So 1 methyl ethyl is the longest chain, and it is still not ethane, because you're still missing one hydrogen because it is still a substituent. Okay, so it is still ending in YL. You note that I put everything in brackets. Okay, it has to be put in bracket because it's going to need a locant. Okay, so here, for example, you can see on this one, the locant is 3. So that's why you need the brackets there. So you can put the locant outside the bracket, dash, and then bracket you have your 1-methylethyl and then hexane. Okay, so that's kind of how it goes. I think what I'm missing here is a dash, so I will fix that. Okay, right there, there should be a dash there, because after bracket also you need a dash. Okay, and so you need to have this group. Just learn to put that in a bracket, okay, because you're going to have to do that in order to have the locant. Now, the 1-methylethyl, this is the IUPAC name for it. IUPAC accepts isopropyl because it's a small group, okay? And why am I teaching you this? I'm teaching you this because let's say that you are naming a cyclohexane compound, okay? We haven't done cyclic yet, but we will. And let's say you have something like this, okay, where you have 1, 2, 3, 4, 5 carbons coming out of it. How are you going to name this, right? So in order to have a systematic way of naming this kind of a substituent, you need some rules, okay, for that. That's why we're doing that. So later on you will see in another slide or so, I have given you all the names in there. Okay, so let's look at that. Okay, here's another example. Okay, so this one is sec-butyl. So butyl, there are 4 isomers for butyl, okay, and I've given those all in the next one. So here is the normal butyl, right? 1, 2, 3, 4. So right here is a connection. Now you can have a connection on the second one, second carbon too, right here, which is this one. Okay, so 1, 2, 3, 4. On the second carbon, you have the connection. So 1, 2, 3, 4. That's where you have a connection. You can have branching also, okay, for butyl group. So 1, 2, 3, 4. So it still has the 4 carbons, but now they're just arranged differently, right? So it's kind of a constitutional isomer. And then here is the last one. 1, 2, 3, 4. Okay, so which means it has 4 different constitutional isomers. So the more number of carbons you have, as we've discussed before, the more constitutional isomers you have. You have to learn how to name all of these differently, you know. And so this one is the butyl, right? That's normal. Like I can handle that one, all right? But then what is this? Okay, so this one is 1, 2, 3. So that's a propyl group. And then on the first carbon, you have a methyl. So that's a 1-methyl-propyl. The general name for it is sec-butyl, which is given right here, sec-butyl. And then the short form is sec-Bu. So all these names that we have, all these alkyl groups we have short names for them too. Okay, so methyl group, for example, is Me, just like you have elements on the periodic table. Okay, ethyl group is going to be Et. So first is capitalized, second alphabet is not capitalized. So Me and Et, like you will not find these on the periodic table, by the way. Okay, so you have all of these short forms for certain groups. Okay, like this. Let me erase this. This is a mess. That's what I do. So in any case, you can see how these names are. Okay, and I'm not sorry, or I am sorry in a way. You know, you have to learn these. There's no other way. The good thing here, this is what I'm not sorry about, is there not that many. Okay, so they're not that many. There's the ethyl methyl is fine, right? It's so easy to do. Propyl only 2, propyl and isopropyl. Butyl there are 4. Okay, so let's go through these ones here. So all your substituents are given here on this slide. Okay, this is the most important slide for that. So you have the methyl group, and I've given you all possible names and ways you can write this. Okay, so ethyl group is Et, propyl group is PR, isopropyl is IPR. And this is what it looks like, and I've given you the IUPAC name also. Now, which one do I prefer? I prefer all of them. So I can handle anything, and I want you to be able to handle everything also. Okay, so 1-methylethyl you can write for me, you can write isopropyl for me. I'm fine with both. Then here are the butyl groups, okay, on this side. So here is the N-butyl, then there is the sec-butyl, where the second carbon is the one that's bonded. That's how you can remember it also. And then here is the isobutyl. The iso part here, remember I told you about the V. Here is the V, okay, so that's the V here also for the isopropyl. So there's isobutyl, then there is the T-butyl, which is the tert butyl. Tertiary meaning 3, so that's the tertiary butyl. So you have 3 carbons coming out of 1 carbon. That's tertiary butyl, T-butyl. And I've given you also the IUPAC name, which is here 2,2-dimethyl ethyl. Remember, this is not ethane because 1,2, it's fine, it's 2 carbons, but it is not ethane, okay? All right, so then the last one here, which I didn't cover yet, this is called a phenyl group, which is coming from benzene. Benzene is C6H6, okay, so -1 hydrogen will give you C6H5, and that's a phenyl group. The short form for phenyl group is pH, okay, not the acidic pH. Acidic pH is this, right? That's acidic pH, and then this is the phenyl group. Our language, our letters are very important. We learned that in Gen Chem also when we are writing elements on the periodic table, and here also, okay? All the alphabets are really important for us. So these, please, all these alkyl groups, remember them, okay? Now, if you're wondering why I don't have any pentyl, you should be thankful, first of all, that I don't have any pentyl groups, 5 carbon groups, because when you get to the 5 carbon groups, there's only one that's actually the more key one, but other than that, you cannot have 5 carbon groups because there are so many of them, right? Because we have branching and whatnot, so you can't have that many. So the only one that is important generally that has a general name for it, see, this is 5 carbon and joint over here. So this is a CH3, this is a CH3, CH3, and this is a CH2, and this is called neopentyl. And you can see it kind of looks like this, right? Because it got so many carbons on that one carbon, it also has a CH2. So neopentyl, neo I remember from the matrix, you know, that's how I remember my things. And then here is the pentyl group coming from 5 carbons. Okay, so that's how this one works out. But that's the only one that has a general name. All the other ones, they actually have only the IUPAC nomenclature, which is good. IUPAC is very thorough, you know, it's completely, you know, systematic, so you don't miss anything. Okay, so here are some general names for the alkane nomenclature. As I said, iso group is that V group. So we don't generally like to call this isobutane, but that would be the general name for it. Butane is butane, and then this is isobutane. And I mentioned to you about the neo group right now. So here is the neopentane. So when you hear about neopentane, then it means that you have 1 carbon with the 4 carbon groups around it. Okay. Um, Generally, I mean, you use these names only if you're working in those conditions, as in like in an industry which uses all these compounds. Otherwise, no. Okay, but I've given them just for reference for you. Okay, so here are some examples for us. Write the names or draw the structures of the compounds given below. So 2,4-dimethylhexane. I mean, writing the names, writing the structure is a lot easier than writing the name, right? Because writing the structure, you like to write the hexane, and then on 2 on 4, you go ahead and write the methyl groups. Okay, to name something, you have to identify the longest chain. That's the important thing here. Okay, and so hopefully all of these I've done correctly, but do go over them, okay, and then let me know if you have any questions, because the answers are given here. I don't feel any need to go over anything. And if you're wondering for this one what happened, why didn't I number from the right hand side for the ethyl group, is because the branching is closer here. If I had the ethyl group on carbon number 5, I would start from carbon number 5 here. That would become 2. Okay, all right. What's wrong with the names of the structures given below? So here, okay, for this one, That's what I was saying I like to do to you, is to give you the wrong name. So first, the thing you should do, of course, is draw the structure out. Okay, given the wrong name, go ahead and draw the, the hexane out, and then on the 2 and the 3, you write the dimethyl, and then on the 5, you draw the isopropyl group out. So then you have this. So once you have this, then you realize, oh, it's numbered incorrectly. The 7 is the longest chain here, okay, not 6. Okay, so 5, 6, 7. 7 is the longest one. So I've given an explanation to you over here as to what's going on with each of these with the wrong names. So again, go over them yourself, see how it feels out for you. Otherwise, send me a message or talk to me, and then I can tell you what's going on. That's it.